All right, we're going to be doing the third practice question. It says we have 100 pounds mass of a saturated steam water mixture. First of all, I like to just write it down on a piece of paper and know this is telling me something. I know I normally deal with 1 pound mass with my specific property. Now I'm dealing with something 100 times greater. So that's going to be a key. And it says I have 100 pounds mass of a saturated steam water mixture, right? So I have a steam water mixture. So that tells me a lot. In the vapor dome, I'm somewhere here. I'm not here at the F point, and I'm not here at the G point. It says the mixture has a quality of 70%. Now I know where I am. 70% along the H sub FG line is where I'm at. So this being F, this being G, I am 70% along the way. I know that. So quality equals 70%. It says assume that pressure remains constant and there is no heat loss from the mixture. It says, and it did tell me I'm at standard atmospheric pressure, so I'm at 14.7 psia at the beginning of this question. Right? So I know which pressure line this is. And I'm 70% away from H sub F, or 30% away from H sub G. So which of the following is the heat needed to increase the quality to 100%? So what I can do is figure out right now the enthalpy of 1 pound mass right there. I know I'm at atmospheric pressure. So I can figure out the enthalpy here and then look up the enthalpy if I was to turn it to a dry saturated vapor. That's just a lookup in the steam tables. So H sub G at atmospheric pressure, if I looked up the saturation right here, where are we? Okay, there we go. So I'm looking up atmospheric pressure, and I come all the way across to see what the enthalpy of a dry saturated vapor would be, and I see it's 1150 BTUs per pound mass. So this would be the enthalpy if I turned it all 1 pound mass to steam, would be 1150 BTUs per pound mass. Well, phooey. 1150. If it were all steam, but it's not. I only have 70%. So I have to figure out what the existing enthalpy is. So that's going to be equal to H sub F plus quality times H sub FG. So now I need to go look up H sub F and H sub FG at atmospheric pressure. So I'm going to do that. So I see that atmospheric pressure, 14.709, 212 degrees. H sub F is 180, and H sub FG is 970. 180 and 970. So 180, and I know that this is BTUs per pound mass, plus quality is 0.7 times 970. 970. All of this being in BTUs per pound mass. So what I'm going to solve is the amount of enthalpy right here that 1 pound mass would have right there. And I'm going to see what the difference is. So the enthalpy of 1 pound mass existing in the vapor dome under those conditions is, let me get my calculator out here. So I'm going to take 0.7 times 970 equals plus 180 equals, okay, that's 859 BTUs per pound mass. So if I subtracted that from right here, 859, this is the enthalpy. 1150 is what a saturated vapor would have. Here's the enthalpy that exists right now, 859. The difference is 1150 minus 859. And if you put that in your calculator, if you're not comfortable with doing that math, 1150 minus 859 is 291. So I need to add 291 BTUs to every pound mass to turn it from a 70% quality water steam mixture to 100% quality steam. But here's the kicker. I have 100 pounds mass to do it. So I have to add 291 to each pound mass. So I need to multiply this times 100. And that will be equal to 29,100 BTUs that I need to add to a 100-pound mixture. Answer, Charlie.